So yeah, this element's bad. Hi, I'm DrewMan. Welcome to my modest mansion. Alright guys, so last night I was taking a shower, which I do most nights. I do that every night, but I don't know why I need to explain my hygiene to you. I was only in there for a couple minutes and I ran out of hot water, which is odd because we have an 80-gallon tank and no one had been showering before me. So I finished up my shower quick while I still had some lukewarm water, and after my shower I came downstairs to investigate. We have an all-electric hot water heater. I don't think they make a hybrid. So just electric. Our hot water here is electric. Came down here, everything looked normal. Went to the breaker box and the circuit breaker for the hot water heater was tripped. So I reset it, and as soon as I reset it, it made some like popping noises. You know, I was like, okay, it's back on. The breaker held, it held all night, but the next morning we still had no hot water. I learned a lot about hot water heaters in a couple minutes, and I'm gonna show you guys how to do some testing to figure out what the issue might be and how to fix it. These things are fairly simple to work on. There's not a whole lot of moving parts to them, especially with these electric ones. And parts for them, like you can pretty much rebuild this hot water heater for under 60 bucks. I spent $66 and it came with a kit that included both elements, both thermostats, which is pretty much the only, you know, parts on these things. As long as the tank's still good, the tank's not leaking, you know, this is still a good hot water heater. We can rebuild it and get some more life out of it. So this is a dual element hot water heater, and it's set up as a non-simultaneous hot water heater. And basically what that means is these two elements will never be on at the same time. In normal operation, the way that this tank works, if the top element is not calling for heat, power goes down to the bottom thermostat. This thermostat calls for heat, it'll kick this on and run until it's satisfied, and then it'll shut off. So your cold water comes in through the cold water line. There's a dip tube that goes down to the bottom of the tank. So we all know heat rises. So as you're using this in your day-to-day, you know, the whole tank is hot, 50,000 degrees or whatever it's set to. So as that cold water comes in, the cold water level is gonna rise as you use the hot water, because the hot water goes out at the top of the tank. As that cold water comes in, it'll come up, and once this thermostat gets to that cold level, it'll kick on this lower element and start to heat that water as it comes in. Well, if you're using a lot of hot water, that cold water level is going to rise, and if it gets up to this top element, it'll kick this top element on and shut the bottom one off. And essentially what that does, it puts the heating element closer to the exit point. So now it's only trying to heat this top, you know, foot of water. So it takes this 80-gallon tank and basically turns it into a smaller, you know, 20-gallon hot water heater. So it'll help with recovery time, and it might help, you know, if you're running out of hot water, it'll keep it warmer longer. So then as, you know, when you shut the water off, it'll heat this, and once the top portion is satisfied, this thermostat will click off, and the bottom one will kick back on and take over and recover the rest of the tank. That's the theory on how this all is supposed to work. So we already got the power shut off to this, and we have the water draining out of the tank. So this top device here is actually an overload. So you can see your black and red come into it. That's your power, 240 volts coming in. And then on the bottom is where the load side comes out. So if there's some sort of overload in here, or something shorts out, this will pop. So if you reset your breaker and you're still having issues, pull this cover off, give that a whack. See if that helps anything. But just remember, these two here are going to have power on them. Mine don't, because I shut the power off. From there, one leg of the 240 goes to this element, and then this other wire goes down to the bottom, and then this thermostat here, you have power coming in on your common, and then it's got normally open and normally closed contacts. So when this thermostat is satisfied, it closes over to this terminal here, which goes down to the other side of your lower element. And then when this one calls for heat, it puts power to this side of this screw here, which goes to your top element, completes the circuit and turns this element on. I'm going to show you how to diagnose this with the power off. We're going to go ahead and take our ohm meter, or our multimeter, we're going to set it to the ohm setting. And like any good person, you got to give it a couple test clicks. Alright, we're good. Send me in. If this is closed, you should have power between these two. So I think I'm having some issues with that overload. But if that overload is closed, you should have continuity between those two screws and these two screws. So then you just want to follow the power down. So I should have continuity from the blue wire down to that element. So that means I'm getting power to this side of that element. So if this thermostat is calling for heat, I should have continuity from the top all the way down to the other side of the element, which means I have power getting to this element. So next you want to check the element itself. So you're going to go across these two here. You see that? I'm getting nothing, which means that this is an open circuit and this element is bad. So now we'll go down to the bottom one. The bottom one's a little bit simpler, not as much going on. So down here on the bottom one, it's just a thermostat. It doesn't have the overload. The blue wire on this side of this element comes up to this terminal here. So this thermostat here has to be open to send power down to this side of this element. And then this screw here is power the other side of that 240 volts. So if this thermostat closes and calls for heat, it sends power down to this side of the element. But now we'll test for continuity across this element. Got 13 ohms. And one thing that I did see on another video was that sometimes you can read through the water, because if the water's dirty and like there's lots of minerals in it, you will be able to read some continuity there. So if you read that number on your screen when you test that, if you look on the side of your element, it'll give you a rating. So these are 240 volt elements and they are 4,500 watts a piece. So if you put that into an Ohm's law calculator, it gives you right around 13, 14 ohms. So that tells me that this element down here is good, this one is not. But if you had like if you're reading through the water, you'd have like a really high number, a lot of resistance, at least you should. But if it's not right around what the Ohm's law tells you it should be, then there's an issue with that element. So basically, I don't know what caused the breaker to trip. When the breaker tripped, the whole tank got cold, and because this upper element was broken or is bad, it was trying to use it to heat the tank. And because the element wasn't working, it wouldn't heat the tank. That's how we had this problem. So I was able to hotwire it to jump around this first element to get the bottom one to heat the tank, which for all I know, that's how it could have been for the past, couple months we've been living here. Maybe it just never got cold enough to kick this thermostat on. We got two new elements. We got a whole kit. It came with elements, thermostats, overload, the whole shebang. So we're gonna set about changing them out. So it just has a couple of spring clamps that hold that there. Once you get them out, that'll just slide right out. I didn't think that I had a socket big enough to be able to remove that, and I didn't, so I bought this tool here. It was like $6. Stick that in there. Wow, that wasn't as tight as I thought it'd be. So yeah, this element's bad. So that's what a bad element looks like. A lot of times they just corrode through. And the actual heat wire is actually inside of this copper tube, and it's got like some insulation around it. And a lot of times they'll end up blowing out like that. I've never worked on a hot water heater. I've worked on block heaters before, and it's the same thing really. So yeah, you can see there's a giant hole there, the giant hole there. Once they get a hole in them, the heating wire inside can corrode and you end up with that. Oh, wow, that's actually pretty clean up here. The anode rod is a little crusty. This is a good time to take a look inside your tank because you're never going to be able to do it again. This is the easiest time to look inside your tank. So this is your new element. Make sure that you put the rubber seal on there. These are not tapered threads, so that rubber washer is what does your sealing, so you don't need to put any Teflon tape or dope on these. That washer there will do all of it. Make sure that the mating surface in here is pretty clean. Hello? Okay, that's good. I try to avoid cross-threading it because that's one way to replace your tank. You don't want to go crazy tight with these because chances are at some point you're going to replace it again. Now when you're putting your wires under screws like this, you want to put it in such a way that as you tighten that screw, it's going to pull the wire in. If you do it the other way, it has a tendency to want to push the wire out as you tighten that. So just a tip. Alright, top element is done. So we still have quite a bit of water draining out of this, so I'm kind of nervous that we might pull this out and take a shower, but whatever. Good news, the water level is below us. So this element was still working, but I figured it'd be a good idea to change it anyways, and you can see there's quite a bit of scale on it. This water heater has been making noise for the past couple weeks. When it kicks on, you can hear it popping, and basically what the internet says is, and you can see it, this is all scale from hard water, minerals in the water. They'll start to form on these heating elements, and when the heating element kicks on, there'll be a little bit of water trapped between the scale and the heating element, so that water has nowhere to go, so it gets super hot, turns into steam, and basically explodes, and it'll blow these deposits right off of the elements, and that's what that noise you're hearing is. But yeah, so we'll get this changed out too. Holy cow, the water level is right below us, and actually I am shocked. This tank is in really good shape inside. Boy, it's good looking. This was manufactured in like 99, the 90th week of 99. So we've already gotten 20 years out of it, and that tank in there looks really good. I didn't see any rust. There was like no deposits in there. So, I mean, those are probably the original elements in it. Alright, both heating elements are in. I think I'm going to turn the water on and start filling it. We still got to do the anode rod and the pressure relief. I probably should check the rating and make sure I got the same one. You're gonna wanna use Teflon or some sort of pipe dope. Alright, that's in. You want to make sure you orientate it so that your relief is facing down. It's interesting that it's holding air pressure because the hot water is open upstairs. But then you should put a dip tube on this, something to, I believe by code, you're supposed to have this go right just about to the floor. That way, in case this does get super hot and blow off, if someone's standing here, they're less likely to get scalded by very hot water. That's what the previous owner left us with, so that's probably what we'll put on there. Okay. Water's up to there. So now we got some water in it. We're going to make sure that our elements aren't leaking. It doesn't feel wet. Alright, now that we got some weight in it, let's give the old anode rod a try. They can usually be found on the top of the tank. Sometimes they might have like a plastic cover over them. Ours is right there. It's a 27 millimeter. Ooh, got something. So really this anode rod isn't that bad, but I just figured while we're doing the rest of this, we might as well change it out anyways. I've never changed out an anode rod before, but these are made out of, this one looks like aluminum, but they're either made out of aluminum or zinc, something that's more attractive for corrosion than steel. And basically this is just a sacrificial piece of metal. It gives the minerals, whatever else, something to eat rather than going after the tank. So there is quite a bit of goop. Yeah, that's not good. You can tell this has never been changed before because it hit the ceiling and I had to bend it to get it out of there. The new one comes as a 3-piece job. So you can see there's 2 spots there, and that allows you to bend it in order to drop it in. These are also pipe threads, so dope it up. Make sure you get it all over the top so when you put it in, you get it all over your fingers. That's why I go get blue. It matches my eyes. Now that's in, we'll go ahead and we'll finish filling the tank, get all the air out of it, and then we can kick this bad boy on and see if we actually fixed anything. Alright guys, tank is full, nothing's leaking that I can tell. And you just want to run a faucet upstairs until all the air stops bubbling. And that way you know that the tank is completely full and you can go ahead and turn those elements on and they're not going to have any issues. Because if you fire those elements up and there's still air around them, or there's no water, they'll just burn right up. So you want to make sure that they're immersed in water. So let's kick this bad boy on. So this should be on now. There weren't any weird noises, no sparks. It's always a good day when you turn it on and there's no sparks. So we are going to check for voltage. We should have voltage on the top element, not the bottom one right now. Yep, 235. And we can also check our amperage, 18.8. This top element is currently heating. So we just got to adjust the temperature on both. Then we should be good. So now we can go ahead and put our covers back on and call it a day. Alright guys, that's going to be it for this video. Hopefully you learned something. I know I definitely did today. Don't tell my wife, but I kind of enjoy when things break like this, because this morning I didn't know how any of this, I know a little bit, but I didn't know that how the 2 thermostats work together and all that. So kind of cool to be able to learn a new skill. By having these two heating elements and the way they work together, if one of them goes bad, it can manifest in a couple different ways. So say you have a hot water heater like this, a big 80 gallon or even a 40 gallon, and it just seems like it's not producing a lot of hot water, chances are your bottom element has gone bad. So it's only using this top element and it's only heating this top portion of the tank. I mean, some of it's getting kind of trickled down, but heat rises, we all know that. So, you know, good place to start would be to check that bottom element, see if you have continuity in what your ohm reading is. And it, you know, if you're gonna drain the tank like this, you might as well just get both elements and just replace it all. It was $24 for the element kit, which wasn't that bad at all. Hopefully it lasts. There were a lot of mixed reviews on those on their app, but it seems like these days a lot of it's user error, and there's a lot of mixed reviews on everything, so I usually take that into account when I'm looking at anything online. Yeah, simple job you can do at home. You know, just be safe about it. If you're not comfortable around electricity or plumbing, you know, consult a professional, turn the power off, turn the water off. That way you don't have bigger issues or kill yourself, because that would probably suck. Never done it, but it probably sucks. If you enjoyed the video, hit the like button, and if you really enjoyed the video, please consider hitting the subscribe button. And leave your thoughts down below. Comment, tell me what I did wrong, right, what you would have done differently. I don't even have to tell you guys, because most of you tell me that anyways. But I enjoy reading your thoughts and suggestions anyways. So have a good day.